in search of the missing data. It was the title of Chipu's PhD from Malawi. I think she's here. That was actually a commitment we did, and in order to be digitalized that level, we need a variety of mobile tools. So Rob will now go into what kind of suite of applications and solutions do we really have to reach the community, the supervisors, and the data coming from the 6th level or the 6+ level as well.
Right, so I'm going to try to only talk 10 minutes, okay? The first thing that I want to do is to apologize about my upcoming presentation, because rather than solving things and make complicated things, offering just too many options, but let's see if it goes well. So let's understand the problem. So we're going down to the community level, and we need tools, and in here we play with the idea of digital tools to collect and to provide feedback and to provide information and feedback mechanism back to the community supporters. We have 3 types of devices, basically. We have the basic phone. We have had that for about 25 years. We have feature phones. These are phones that may be able to have a very simple web browser, but certainly they don't run applications. And sometimes they run very specific applications, and those phones are quite common in the African market and some of the Asian markets. And obviously we have the smartphones. There is a great variety of phones going from $100 and sometimes a little bit less to $1,000 plus. And they basically basic phones. So what kind of technologies do we have available in a basic phone? We have SMS, we have something that is called USSD, and I'm going to be talking a little bit about it. And we have voice. Sometimes I feel that we constantly forget about voice. We can still use the phone to call someone. Or you can actually interact with an automated system that is an IVR. And I'm going to talk a little bit about that. The featured phones, they normally offer a very simplified web browser that has limited functionality. You cannot run very sophisticated web pages. And there is also something called J2ME, and the university also have more than 10 years experience of working with J2ME. I'm going to be showing some of those examples. And obviously we have the smartphones. There is fundamentally 2 platforms out there, Android and iOS for now. So let's start looking into each one of these technologies and understand the options that we have, and in what ways we can integrate those technologies with DHIS. So again, let's not forget for whom we are working. We're working for the community health workers. They can be reaching our beneficiaries directly at their households, directly in the communities, in the villages where they live, or they could be actually doing these processes in some facilities in district level or so forth. Start with SMS. What can you do with SMS, and particularly what can you do with SMS with DHIS out of the box today? This has been available 5-10 years, I don't know. You can actually send a message to a number, and it has to be a structured message that the first word is a keyword. So in this example, REC is record, but then you have identifiers of each data point. Or actually, in this case, this is kind of aggregated. And RD is a data element, and the value was 50. AA is another data element, and the value is 17. AB is another data element. So it could be number of measles vaccines given, 50. Number of smallpox vaccines administered this week, 17. Number of, so basically you have converted a simple aggregated form in a series of data points that have 2 letters that identify the data point, then you have the value. And actually, this is a screenshot from within the SMS engine in the HIS. You receive those messages, and those messages are coming from a number. So 254 is the full number. That number is associated to an OR unit, and then that becomes the reported information for for the given period, that is the day when the report was received. These have been working for years, and actually there are certain things that you need to take into consideration. You go into the DHIS2 mobile configuration SMS commands. You can actually set up the mechanism to parse the messages that you receive in terms of how do they associate to a data set, how do they associate to an event, to an enrollment. It supports both aggregated and tracker. There are some limitations. One of them is that the person that is sending the SMS becomes the OR unit, because you are doing a direct association between the person, the telephone of the person sending the information and the OR unit. So that's the way that you can do that matching. It also normally requires a contract with a local telecom provider, as you need to have an incoming gateway. The ideal situation is that you contract with something that is called an aggregator that is able to have a single number for the whole country, that it can process all incoming messages regardless of the network. In most cases, you can actually do it. It should be possible to contract as a toll-free number, so that means that no one has to pay when they send in the messages. It will not come from the credit on the phone. So let's move to the next option. USSD. So in the Western world, North Europe, people don't even know that this exists. But in East Africa, everything happens over USSD. Is telephone banking, mobile money is running in USSD. You may have used it sometimes. Normally you start a command with an asterisk and hash, put some numbers, and basically you start getting some sort of a menu-based system where it tells you option 1 to do monthly reporting, option 2 to do weekly reporting, option 3 to add credit to your account, and then you press one number and then it goes into the next menu and so on. So you normally, there are many USSD projects running for the integrated with the HIS. I know in Tanzania, I know in Uganda, I know in Kenya. They're normally the implementation involves deploying an application with this aggregator. It gets written by this aggregator, and then there is just simply an integration on the back end back to the HIS over the API. In most cases, it's aggregated information, or it would be event-based information. HISP Tanzania yesterday showed me an incredible application that they have built that allows to expose and allows to map the whole setup of the HIS to through a web app and make that a full menu that then can be exposed through a USSD connection. So this is an example of this is running in the HIS. So in here you're actually building the menus of that USSD system. Immediate reporting, weekly reporting, submitted weekly report. And basically when you start your USSD session, you're going to be exposed to all these options. As you continue, you're going to start digging into a data set or digging into a program, and then at a certain point you get asked for the value. You can talk to HISP Tanzania. As far as I know, this is kind of experimental and it's not yet publicly available. But I found it completely fascinating that they're exposing the whole data model and convert it into USSD. You can do your mapping, and then you can basically get everyone interacting with it. So let's go to voice. Yes? So there are two ways that you can use voice. So one of them is what's called IVR, is interactive voice response. Everyone has gone through this process of welcome to this, press 1 to talk to sales, press 2 to this. You can perfectly do this with the HIS. I'm not aware of an implementation. Maybe some of you have this kind of implementation. There is all kind of technologies for doing this. Normally this is running on the cloud, or it could be a local server. There is open source technology for this. But the way that it will work is that you will call, and then there will be a menu of options. Press 1 for immediate reporting, press 2 for weekly reporting, press 3 for submitting the weekly reporting. You press one number, goes into the next menu. If you're reporting a debt about this, press 2. If you're reporting a debt, and then you go and go and go. And what you're doing is that you are filling in a data set, you are filling in an event. But you're using selections, or you can actually be using voice-activated voice recognition. There is all kind of technologies out there. The other thing when talking about voice and that we should not forget is that you can still talk to a human. And maybe this is the cheapest way to get information. You can have a call center, you can have a hotline. It's a matter of making sure that there is someone else on the other end of the line that can respond to that call. And that person is sitting in front of a laptop that is connected to the HIS, and you can capture the information. And this is probably very easy to deploy and actually not that expensive to run. So J2ME, I've never used it. I don't know anything about it, but there is a lot of experience within the community in deploying J2ME. It has some challenges in its deployment. How relevant is this nowadays with the access to all these smartphones is something that we need to question. But again, we're exposing data sets, we're exposing events. Up to the previous slide, everything was based on basic services. They were actually more in online, because to send an SMS you need signal. To do a USSD session, you need signal. They do not work offline. To do a voice conversation, you need to be connected to the network, even if it's a basic service. So J2ME is, this is the first one that we're showing that it will work completely offline, but I really will question the use of J2ME nowadays although I know that, as far as I know, I think there are still some of these implementations up and running. So next one, the mobile browser, is I feel that we keep thinking that everything has to be offline, but the availability of 3G and 4G at very affordable prices is happening very rapidly. You can go to many countries in Africa and Asia, and you pay $3 or $4 and you get 1 gig. And obviously, you go really deep into rural areas, there is no connectivity. But when you're in urban centers and mid-sized villages, sometimes you have better connectivity. The one that I get in Spain or London or in Norway is sometimes it's surprising the quality of the signal, and it's 4G all the time, and it's cheaper. In many cases, it's much cheaper than what you pay for a gig here in Europe. So the biggest problem here is that this is normally online only. Yes, you can develop some kind of offline functionality, but I think to really get this working offline is very complicated. So I wanted to show an example of something that PSI has up and running. Because I think it's, especially thinking about the feedback mechanisms, it's just a very quick presentation, but I think it shows the power of how can you distribute feedback. So the way that it works is that they do an assessment of the quality of, the quality assurance at the facility level. And then at the end of the assessment, they have captured all that information in a tablet, they send it to the server, and then what they do is that they send an SMS to the provider and say, your detailed feedback is now available in this address. And what happens is you just open a very simple web page, and you have a series of information about which ones you pass, which questions do you pass, which ones do you fail. But then, actually, if you click into any of those questions, you get further help in terms of a kind of a job page about what is the way that these particular standards should be passed or not. Anyway, the important thing is that this is a simple web page that got written in less than 10 hours. And what you have here is just data elements that are being presented in a very interesting way for a particular unit, for a particular event. So all I'm saying is that the web browser, I believe that it has a space. And you can actually do things very quickly, just it only works online, but it's an option sometimes, and you can use it in combination with the SMS. Okay, so next option. So now we're moving into smartphones, apps. Basically, we were talking about Android and iOS. So we have the first-party app that the university provides. We saw on Tuesday that we have had for the last 3 years 4 applications, 3 for data capture, 1 for the dashboard. We're moving into a new generation of apps. So there is other interesting applications that HISP Tanzania had been working on. They actually have a data capture app that they call HISP Touch. And then they have another one for dashboards. And they are building a kind of technology that makes that both of these applications are available for both Android and iOS. So I encourage you to get in contact with HISP Tanzania and evaluate the possibility of using those apps. And then you have all these other custom apps that are being built by other people. In many cases, they are either forks of the original apps, or they're using the underlying technology, and that's exactly what we're trying to promote in using the SDK to build new technologies. You go to Google Play, you type DHIS2. This is what you get in Google Play nowadays. And if you look into the Apple Store, I did manage to find it. They are there. They are published there. So one more piece, and something that's happening and we should be thinking about. I know that there is people exploring this as an option, is the use of chatbot technology. And WhatsApp have over 1.2 billion, so 1.4 billion users. Messenger from Facebook have another 1 billion, and there is Kik, Line, Telegram, many stuff out there. So certainly that's, I don't know about any live implementation using chatbots, but I do know about many people exploring the possibilities. I can easily think about exposing an event. You can even have all the event rules showing and hiding questions as you go through. So certainly that's kind of something that we should be exploring as another way to interact with community health workers. So in terms of where should we actually be thinking of where to focus, feature funds are declining in terms of shipments. We're looking into 2-3 billion units of mobile devices being shipped every year. And obviously the projections of all the different companies out there that do research and analytics are looking into, we're inundated in the market with over 2 billion devices every year. So certainly we need to think about those devices. Again, these are the options. Which one is the correct one for your project? Which one is supported by the HIS now and tomorrow is something that we're constantly exploring. That's it.
We are not finished. Can you hear me on this one? No, it's no battery. So we have to share that. We worn out the battery in the last end. So what our point is that please come all of us here. Our point is that at the community level we really need to be smart, and there's no solution fits all. We have seen from the use case bazaar, the Honky PSI app, the supervisor app on Android. You know, supervisor can have very more advanced applications. We can go at the community level. It can be voice, it can be SMS, it can also be Java apps, and it can be browser we know that every country is using WhatsApp also for information and making groups. Hangout, WhatsApp, whatever technology that cannot connect people. So we need to be smart, and we need to see that there is a level of solution that work together in an architecture. And our research project here at the university that started already in 2010 was how can you cater for whatever you have in your pocket, and that what you have in the pocket change during years. It's not like Hanan said, waiting in Bangladesh until all the Facebook generation is there to stay on the, going upwards, because then everyone know how to handle an Android phone. So the technology is working for us, but we always need to bring everyone on board, and that cater for many different